For the best viewing experience, please rotate your phone to landscape mode. If you are watching on YouTube, simply tap the full screen icon in the bottom corner. Let's get started. Okay, so now I want us to look at fractional distillation. Now, what does fractional distillation do? It separates two or more miscible liquids with different boiling points. For example, ethanol from water or crude oil into its fraction. Now, you need to know one key term here. This key term is miscible. What it means, liquids that mix completely and form one layer, such as ethanol and water. Unlike, for instance, cooking oil and water, where you have to have cooking oil floating on top of water, you see, and hence in that situation you have to use a method called decantation or decanting. But miscible, these liquids completely mix together to form one layer, so you can't tell whether there is something in there or not. All right, boiling point, obviously the temperature at which a particular liquid turns into gas. Fractionating column, a tall column usually packed with glass beads, giving the vapor a temperature gradient to climb. All right, now let's have a look at this. Now, what do we do with fractional distillation? So number one, what you need to do is to heat the mixture in the distilling flask. All right, the liquid with the lowest boiling point, number two, the liquid with the lowest boiling point boils and evaporates first, as you can see. All right, the vapors rise into the fractionating column. So this can be our fractionating column, which is hot at the bottom and cooler at the top. So it will be hot at the bottom and cooler at the top. This will allow the liquids with the lowest boiling point to condense first. Then number four, the vapor of the higher boiling point liquid condenses on the glass beads and trickles back into the flask. So hence what may happen now is liquid with the higher boiling point will condense and go back first to prevent all of them from going to the condenser. All right, number five, the vapor passes into the condenser, cools, and is collected. The thermometer holds steady at its boiling point. If you go back to states of matter, you realize that the thermometer will remain at the position it's at until perhaps all of the liquid with the lower boiling point has evaporated. Just like when there is ice also in a beaker of water, what happens now is the thermometer will hold steady at 0 degrees until all of the water has evaporated, all of the ice has melted, in fact, and hence you get to see a temperature rise. So I believe that this is also the purpose of these glass beads. The temperature will hold steady at the boiling point of the lower liquids, of the liquid with the lower boiling point, until all of it has evaporated. Number six, when the thermometer reading rises, change the receiving flask and collect the next liquid, and that's how you go about it. All right, so this is how we go about fractional distillation. If you want notes which also show you the step-by-step processes of fractional distillation, just write notes at the bottom of the video and you will have a copy sent should you be willing to join our online classes as well as the face-to-face classes. You should also link up with me on +263 777 992 527 if you be interested in signing up for classes. We go on to the next method of purification.